Hi, Software Engineering 101 Lecture 7. This presentation will explain important steps of the software requirement analysis. It is a crucial part of making software successful. We will break down it to make it easier to understand requirement fundamentals, requirement activities, requirement analysis methodologies, process-oriented analysis, and object-oriented analysis. Adopted from software engineering, a practitioner approach. Introduction. Requirement analysis, also called requirement engineering, is the first step in making software. It is a methodological process of finding, gathering, writing down, and understanding what people want from a system. These wants become the rules for what the system should do and how it should work. We figure out these rules by talking up to clients, users, and other people involved. Think about creating an online banking system. Requirement analysis is like solving a puzzle of what different people needs. Customer want smooth transactions, bank staff needs tools to manage things well, and administrator wants strong security, understanding, and blending all these needs is really important to make good software. Role of analysis. The role of the analysis is multifaceted, involving tasks such as eliciting requirement, gathering information about what the system should do from different people involved, resolving different views, finding a solution when different people have different ideas about what is needed, advising on feasibility, giving advice on what's possible and what is not within the given constraint, clarifying requirement, making sure everyone understands what's needed and why, documenting requirement, writing down all these the rules and expectation from the system, negotiating a user agreement from the specification, making sure everyone agrees to what the system will do. It is crucial for the analysis to facilitate effective communication and collaboration between the development team and the client. During requirement analysis for a new software project, the analyst may conduct interviews and workshops with stakeholders to elicit their requirements. They might encounter conflicting opinion or unclear expectation, requiring them to facilitate discussion and find consensus among the stakeholders. Additionally, the analysis plays a crucial role in documenting these requirements in a clear and understandable manner for both the development team and the client. Requirements fundamentals. Requirement serves as blueprint delineating the services a system must provide, the operational parameter it must adhere to. They act as a bridge between stakeholders' needs and the system's decision and development process, guiding the creation of software that meets user expectation and business objectives. Types of requirement, functional requirement. These delineate what the system should accomplish in terms of task and operation. They specify the functionality that the system must support to fulfill user needs. In an e-commerce website, a functional requirement could be allow user to add items to their sport shopping cart. This defined as a specific action that system must enable user to perform. Non-functional requirement. These specify how well the system should perform its function, focusing on qualities like performance, usability, security, and reliability. In the same e-commerce website, a non-functional requirement could be the website should load within 3 seconds. This sets a performance expectation from the system, ensuring a satisfactory user experience. Characteristics of good requirements. Clearness. Good requirements should be clear and unambiguous, ensuring that stakeholders understand what is expected from the system. Clear requirements facilitate effective communication and reduce the risk of misunderstanding or misinterpretation. Instead of stating the system should be fast, a clear requirement would be the system should respond to user queries within 1 second. Consistency. Requirements must not contradict each other, ensuring coherence and integrity in the system design. Consistency helps maintain a unified vision and prevents confusion or conflicts during the development. If one requirement states the system should support online payments, another requirement should not contradict by stating this system should not process online transactions. Completeness. Good requirements cover all aspects of the system's functionality, leaving no gaps or ambiguities. They provide a comprehensive overview of what the system should do, ensuring that all relevant features and behaviors are addressed. For a customer relationship management, uh, a complete requirement would include not only managing customer contact but also tracking sales, leads, recording customer interaction, and generating reports. Verifiability requirements should be testable, allowing stakeholders to verify whether they have been implemented correctly. Verifiable requirements enable objective evaluation of the system's compliance with user needs and project goals. A verifiable requirements for an e-commerce website could be the system shall send an email confirmation to user after a successful purchase. Attainability requirement should be feasible within the project constraint, considering factors like time, budgets, and available resources. Attainable requirements ensure that the system can be successfully developed and delivered according to stakeholders' expectations. If the project has a tight deadline, an attainable requirement would consider the time constraint and specify only essential feature to be implemented within the given time frame. Requirement activities. Requirement analysis unfolds through the series of structured activities. Elicitation, gathering requirements from stakeholders through techniques like interviews, survey, and workshop. This phase involves activity engaging with stakeholders to identify their needs, preferences, and expectations regarding the system. Techniques such as brainstorming session and focus group can also be employed to extract valuable insight from stakeholders. In developing a new mobile banking application, stakeholders might be interviewed to gather requirements on features such as account balance, checking, fund transfer, and bill payment. Analysis, understanding and refining requirements using methods like use case, user stories, and prototypes. This phase involves discussing gathered requirements to identify pattern, dependency, and potential conflicts. Techniques such as requirement prioritization and feasibility analysis help in refining requirements and identifying the most critical feature for implementation. After gathering information from the mobile banking app, the development team might analyze user stories to understand the flow of actions users would take when transferring funds between accounts. Specification, documenting requirement clearly and systematically using diagram, documents, and models. This phase involves translating, gathering, and refined requirement into structured format that can be easily understood by all stakeholders. Techniques such as creating user case diagram, activity diagram, and requirement traceability metrics add in clarity, specifying the scopes and detail of the system requirement. The requirement for the mobile banking app could be specified using use case diagram to illustrate interaction between user and system, along with textual description detailing such as each use case behaviors. Validation, ensuring requirement align with the stakeholder needs through thorough review, walkthrough, and prototyping. This phase involves validating the documented requirement to ensure that they accurately reflect the stakeholders' expectation and business objectives. Techniques such as requirement review, user acceptance testing, and prototype help in identifying discrepancies and validating the feasibility and usability of the proposed solution. The development team might conduct walkthrough with stakeholders to review the documented requirement and validate the accurately capture and desired functionality of the mobile banking app. Management, tracking changes and maintaining requirement integrity using specialized software and version control systems. This phase involves managing the entire life cycle of requirement from their initial identification to their implementation and beyond. Techniques such as requirement traceability, version control, and change management process help in ensuring that requirements are effectively tracked, documented, and updated throughout the project lifecycle. Throughout the development process of the mobile banking app, changes to requirement are tracked using version control system like GIT, ensuring that all stakeholders are aware of modification and their impact of the project. Requirement analysis methodology. Various methodology guide requirement analysis, waterfall model, sequential development phase with upfront requirement analysis, sustainable for projects with stable requirement, building a website where all features and functionalities are defined upfront and each phase requirement, design, implementation, testing, development follows sequentially. Agile methodology, iterative development with continuous stakeholder feedback, ideal for project with evolving requirements. Developing a mobile app where features are implemented incrementally in short iteration, allowing for flexibility adoption to changing user needs and market trends. Prototyping, building simplified version to gather feedback and refine requirements common in user-centric projects. Designing a new user interface for a software application and creating prototype to demonstrate the layout, navigation, and functionality to stakeholders for feedback and refinement. Use case analysis, identifying a system interaction through scenario of use crucial for defining user interaction, analyzing the requirement for an online shopping platform by creating use cases that describe how users interact with the system, such as searching for products, adding items to the cart, and completing the checkout process. Process-oriented analysis. In process-oriented analysis, various techniques help in understanding the system's process and data flow. Diagrams, visualizing the flow of data within system. In hospital management system, DFDs show how patient information flow from registration to diagnosis, treatment, and billing, illustrating the movement of data between different departments and process. Entity relationship diagram ERD, modeling relationship between entities in a system. In an online bookstore, ERDs depict relationship between entities such as books, customers, and orders. For instance, one ERD might show how each customer can place multiple orders and each order can contain multiple books. Structured analysis, decomposing a system into a smaller component for better understanding. In inventory management system, structure analysis involves breaking down the system into components like stock taking, ordering, and reporting. Each component in further analysis to understand its input, process, and output, enabling a detailed understanding of the system's functionality and interactions. Data-oriented analysis. Analysis method in data-oriented analysis focus on understanding and managing system data. Data directory, defining data elements and characteristics to ensure consistency and clarity. In a customer relationship management system, a data dictionary would define attributes such as customer name, email address, and phone number along with their data types, length, and validations rule. Normalization, organizing data in relational database to minimize redundancy and dependency. In a database for an e-commerce platform, normalization ensures that each piece of data such as customer information or product detail is stored only once, reducing storage space and ensuring data integrity. Object-oriented analysis, identifying object and interaction to understand system behavior, crucial in object-oriented design. Example, in developing video games, object-oriented analysis involves identifying objects such as player, enemy, and weapon, along with their attributes and behavior. This help is designing classes and relationships that accurately represent the game's worlds and mechanism. Thanks for watching. If you are enjoying the content, consider subscribing, hitting the like button, leaving a comment, and sharing it with others. Thank you.